Good morning, everyone. Thanks for letting me jump into your morning. Hopefully you've got a nice hot coffee beside you. I'm just going to try to see if I can work this technology, which I should be able to, since I'm presenting about technology. That's me. And this morning we're going to talk a little bit about why coding is part of the curriculum, why it's important in my mind, and what's actually in the curriculum, and then hopefully give you some places where you can help your teachers get started in implementing coding and computational thinking, which is probably a new word to some people, into their classrooms. Currently, I'm principal of Rob Road Elementary School, a French immersion school here in the Comox Valley, and Kevin covered the rest of my little introduction I was going to say. Feel free to walk out of the room because I won't notice if you do, and I'm hoping to be done by about 7:50 or 7:52 at the latest. So let's start with why. Why is computational coding and computational thinking important? I think it's right up there with critical thinking and creative thinking. I think it probably should be one of those thinking strands because, and I'll define that in a little bit, and coding is just a little tiny part of computational thinking. Some of the research that we saw in that Coding Advisory Council told us that BC is going to be short workers for 20,000 tech jobs across the province by the year 2020. Right now, they can't get enough local BC the business industry to get more kids into computer science and ready for those jobs, those technology jobs. One thing they also showed in the research is that someone who's in a technology field, as compared to a similar job in a different field, can earn up to 20% more on average. So these are good paying jobs that we need people to fill, and the business community is really looking to the schools and universities to fill those spots. Outside of the tech industry, there's many jobs out there that need technology skills as well. I mean, in my 15 years of teaching, you see a huge change in technology skills and the thinking skills required by teachers just to do the teaching job. So that's just an example of how we have to have these skills for other areas. Let me start by getting into some nuts and bolts, some boring stuff about defining what computational thinking is. There's 4 parts to it. First one is decomposition. I'm going to try to give us some examples here, so I'm not just reading the slides. That drives me crazy. I'm going to try to give examples of what principals and vice principals are doing, what I'm doing in my job, and how it involves computational thinking. So decomposition, breaking down small problems. Right now, I'm looking at building our staffing grid for next year and deciding who's teaching what courses and what people we need to hire. That's a really big problem that I need to break down into little small bits. Today, that little bit is doing some reference checks on some people we're trying to hire. The next part of computational thinking is patterning. One example when I'm thinking about it as my principal job, when I'm dealing with a student with some complex behavior challenges, I'm always looking for patterns in the behavior. So is there a certain time of day or a certain subject area that's triggering this student, or what are things are happening before that's causing the behaviors? That's patterning, and we make decisions based on those patterns. The next one is abstraction. Is going from one specific idea and making it more general. So I'm doing a teaching report right now, an evaluation on a teacher, and based on a few observations, those specific observations, I have to generalize to the teaching practices and pedagogy of the teacher and make statements about the quality of their teaching. And the fourth one is algorithmic thinking. An algorithm is just a step-by-step process. So as a principal, like I said, I'm building the staffing for next year. I'm also building classes for next year. Last week we had the teachers sit down and put kids into classes. This week we're sitting down with school-based team and analyzing those, and next week we are making a bit of adjustments with teachers again. So you can see that computational thinking, none of that involved a computer. So don't think that computational thinking is just computers. It's just a different way of thinking about things. And coding is a part of computational thinking. It's a skill within that thinking process.
Hi, Kyle. Just a lot of stuff. Sorry to interrupt. There's just, I don't know if you can see it on your screen. There's a pop-up for a Mac ad just when it's getting in the way of it. There you go. Thank you.
Done. Done. Thank you. I can't get rid of that pop-up. It keeps coming back. Sorry about that. So coding is underneath all of this technology, and I think this picture kind of reminds me that you gotta surf the wave, but you also gotta realize what's underneath you. All the kids that are using technology, we're using technology. Everything that's underneath there has all just been coded. So in order for us to be able to create using technology, we have to understand a little bit about coding. I don't know how that wave ended, but hopefully it worked out for that guy. So let's get right into what is coding. I like this definition. It's the skill of breaking down instructions so simple, even a computer can understand them. Computers are not smart. They just follow instructions very well. They follow them exactly, and they follow them very quickly. The programmer, the coder, is the person who tells the computer what to do. We used to call this programming. Now it's called coding. When I started, my experience in coding is first year computer science at UVic. I don't know if anybody was in Computer Science 101. I was just very happy I had some engineer friends that helped me through that course, and I didn't have to take Computer Science 200. Coding can take many different forms. I have done a little bit of work with code.org, and I'll show you that. Right now I'm teaching some grade 7s to use Scratch. Really they're teaching each other, and I'm just there facilitating it. There's tons of different coding languages. You've probably heard of HTML, Java, Python, a bunch of them. I'm going to show you a couple of examples here of some very simple coding that I've actually done with primary age students and my 6-year-old son, and then some more advanced stuff. So I'm going to just see if I can jump to my, hopefully you guys can now see my screen. This is Code Studio or code.org. This is the next step after hour of code. And I just want to show you how simple coding can be. This is a visual programming or block coding. So what I want to do here is, or what the student wants to do is get the red bird over to get to the green pig. What do I have to do? I have to move forward 3 times. I have to turn right. I have to move forward a couple more times. So the student can put these blocks into place. They hit run. Hopefully this, you can, I don't know if you heard that, but it's just making a funny noise for the kids. It turns right. And it didn't work. So I can reset that. Hopefully you guys can't hear that audio because it was really annoying to me. I can reset that and I can fix that. It went too far forward. I have to actually turn left a couple times, move forward a couple times, turn right, and then move forward again. So if I run that again, you can see that there's some problem solving, some trying to critically think of through what's happening, and hopefully I figured this one out. There we go. So that's code.org. That's an example of some very simple coding. Coding can also be really advanced. So here's just a piece of the language that's sitting behind the PVPA website. So here's the BCPVPA website. And if I click on View Source Code, you can see that underneath of it, it's actually all coding language. This is written in HTML. And all these little bits of things mean things. They don't mean a whole lot to me. But if I look right here, I don't know if you guys can see my highlighting here, that little line there is basically telling the computer to go find an image, and there's the address of the image, and make it 150 wide and 40 high, and show it on the screen. So that's just an example of HTML coding, and you know, there's kids that are doing this, which is pretty impressive because I sure can't do it. Let's jump back to the presentation. There's my examples. And move on to a little bit to BC curriculum. The new BC curriculum, as you know, the Applied Design Skills and Technology curriculum. If you're looking at kindergarten to grade 3, the competencies are pretty simple. There's 3 things there: ideating, making, and sharing. This doesn't require, there's no coding anywhere in the curriculum until grade, I think grade 6 or 7. But what we can do is we want to implement these competencies across other curricular areas. An example is my kindergarten teacher said, how do I do ADST? What does that look like in a kindergarten classroom? And I said, you know, if your kids are playing, if they're building, you got a group of kids in the corner building, let's say they're making a ramp to drive their cars down, because that's what the boys in my kindergarten class like to do. They're ideating. They're coming up with that idea. Let's see if we can get this car to shoot all the way across the room by building a ramp. They're making, so that making process involves building the ramp, building it up higher, finding the right blocks, debating back and forth about how to make it straighter. You know, all those things the kids happily do together. There's never any arguments. And then finally sharing. They love it when I happen to walk through the classroom or someone else in their classroom, when they do get that car to shoot all the way across the room, they love to share that. That is the design process at a very simple level. As I mentioned, kindergarten all the way up to grade 5, there's no coding and there's no actually content in the ADST curriculum. There's the competencies, there's the big ideas, but there's no content. So that's encouraging teachers to go into other areas of their curriculum and then apply some of these ideas of the ADST curriculum within that. As you move up, looking at grade 4 to 9, this process is the same. It ends up at the same place of sharing their product. It just adds in some more details. So hopefully you can see that it's a bit small, but this is happening in lots of places: shop classes, computer classes, art classes. One example from a classroom in my school is I had a grade 5 teacher. He had his kids in the class building math games out of cardboard, similar to the Canes arcade video you may have seen a few years back. So students went through this process, and even though they didn't know they were going through the process, because maybe he didn't use this language, if they understand this language, they're doing design. They had to understand the foundational math principles behind the games and the statistics they were doing, or probability, I guess. They had to define what they wanted their game to do, come up with ideas, that's ideating, prototyping, so they built a prototype and they tested it out, and then they made their final product and improved their final product. And then for that group, they actually shared their products at a district inquiry fair last week, and this week they're inviting classes into the school to play into their classroom to play their games. So they're getting a good chance to share that across the school and across the district. This is ADST, and he's doing it within the math curriculum of grade 5. The ADST content in grade 6, 7, 8, and 9, you can see it there. There's a bunch of different modules that they talk about. Students in grade 6 to 7 take 3 of them, and not all of those are technology or computers as you traditionally think. Some of those are what we would used to call the shop classes. In grade 8, 9, they took a full year course, and the school can offer different modules of this to different students. If you're a small school, small high school or middle school or K to 9 school, and you don't have specialists doing these, there's lots of resources out there that could at least help take care of the computer science and coding sections of this. Hopefully you've got, at older grades, you do have specialists that are doing metalwork, because that would be a challenging job for a principal. So, hey, I'm getting ahead of time here. This is good. What can you do? I think what we can do as principals and vice principals is encourage teachers to integrate this into all their other curricular areas, especially at that primary level, and use the language of that design process as kids are playing or as they're building or making a project. Use that new language, and then they'll be able to apply that language later on when they're doing more advanced work. Don't be afraid of the technology. Let the kids be the experts. Like I said, I was facilitating kids using Scratch. I just gave them a little cheat sheet, a little starting place on Scratch, and then I relied on the experts in the room. I had 5 or 6 kids that could teach a whole bunch of good things about Scratch. It was one of the coding languages they were doing. I'll show you in a few minutes some of the stuff on codebc.ca for coding. There's lots of good resources in there, and I'll show that in a few minutes. And that's a great place to start and to show your teachers if they haven't looked there already. Oh, here it is. So CodeBC is a website that's created by the computer using educators of BC, working with the Ministry of Education to put a bunch of resources together in the same place. So I'm going to go again back to my web browser because it's better to show you on there than to, there it is. So here's codebc.ca. This is, you can see there's lots of resources. If I click here in resources, there are a bunch of French resources, which is great. I work at a French immersion school, and they're always asking me, oh, but is this in French? Yes, it is. And you can search these resources by all kinds of different areas, grade level, subject area, all those down the side there that you can see. The one that I like, being a principal who's often running in to teach a class at the last second, is advanced preparation. So if I want something that's low preparation, I can just walk in and do. I can look for those. It doesn't require teacher expertise in any of these areas. I just want to also show you one other resource type here is offline resources. So if I go down here and click search, it's going to pull up a bunch of resources that don't require any technology or computers to teach kids. And I was hoping to find one. There was a great one that was just a PDF printing out. Basically, you're getting kids to program each other. One kid acts as the robot, and the other kid writes out a list of instructions, and the robot follows the instructions to complete a task. That's real simple coding that students can do without a computer at all. You'd have to go in there and find it later. Sorry, I don't want to spend time digging around to find it right now. Because I want to just show a couple other things here. There's a Pro D section in here. If I click on courses, there's just one, I think, but they're building the site. This Teacher's Guide to Computational Thinking is actually really good, really simple. It's got some great little videos to introduce this to teachers. And this is kind of where I started and got some of the resources for this presentation today. Finally, I want to show you the mentorship. So they've actually got a mentorship map here of BC, and it's, again, just starting out, but we're hoping that you can find mentors, or if you are comfortable with this, you can become a mentor somewhere for someone and help each other out. There's somebody in Port Coquitlam who's a mentor and offering. I put my name in there, but I don't seem to show up. Maybe I don't qualify. So this is put together by BC teachers for BC teachers with the BC curriculum in mind, and it's a really good place to start rather than just randomly searching all over the place for coding resources, because you'll end up with some stuff that's doesn't really fit with the curriculum. I'm back to my PowerPoint presentation and asking for questions, and that took me 19 minutes and 36 seconds. So hopefully you guys have some questions to fill up our last 10 minutes. Kevin, are you still there, or did I put you to sleep?
No, I am there, Kyle. I did have one question for you, and so this comes from Kim Bailey Cook, and she asked, what specific strategies are you using for staff to encourage ADST in the classrooms? She said she's done a learning lunch and divided into a couple of classrooms to model what I know. I'm looking for strategies to motivate teachers to buy into ADST.
I think learning lunch or small groups is great. I mean, those are good strategies. I think to buy into ADST, well, part of what I would say is that it's required. It's part of the curriculum. We don't have to have teachers buy into math, so it's something that we need to do, and we also need to make it so it's not intimidating to teachers. You know, the example I gave of the kindergarten teacher using the language of ADST during the play time of kindergarten students. That's ADST, and that's something we can report on, and we use portfolios to report. But it's just using that language and stuff that we're doing anyways.
Yeah, thank you, Kyle. I think that's a great answer. I think, what I'm hearing around the province, I think particularly for our primary teachers, perhaps who don't feel comfortable with the technology, I think just shining a spotlight on what they're doing already, and that, those makerspace areas and those opportunities for kids to, as you say, ideate and create really are part of the first baby steps that we're taking with ADST. So I think that certainly would help to alleviate some of the anxiety around there. And I think also your point about not having to be the expert, right? Our kids, I think we create the space for kids to really share their own strategies and their own knowledge, and sort of step back and watch the magic that can happen with that type of approach.
Yeah, I'm just going to try to find that example here from Code BC, the one I mentioned about the robot coding, kids coding each other. It's a really simple one that absolutely any teacher could do at any grade level. There it is. So it's called Robotic Students, and it's just like any teacher could do this today in their classroom with absolutely no preparation other than printing out some handouts.
Right. So we have another question, Kyle, from Sharon McKay. She's and you might this might have come up at the Provincial Advisory Committee that you sit on. So she's wondering about how we report out on ADST. And she says in middle school we have our explorations, which makes sense. But what about classroom teachers and reporting on what's happening in their classes?
So this year, I think the ministry requirement is that we report just once at the end of the year. I think as a sort of a transitional year, and it should be, if you're using My Education as your reporting tool, it comes up as a subject area just like anything else, and it should be reported out at least once per year. If you're using portfolios, our district uses a lot of portfolios. It's a great way. Kids can upload the work they've done and pictures and everything else and report that way. So does that answer that question?
Yeah, I think so to some degree. I think we're still all figuring this out. I think it would be nice to have some clearer directions on that, but I don't know if your Provincial Advisory Committee is meeting again, but certainly I think we, in the field, will be looking for some more direction or some options in terms of how we are reporting. I've got another question for you, Kyle. It's from Reed Findley, and just wondering your insights into, and a secondary question. I know you started as a secondary teacher. Insights into 2-credit versus 4-credit ideas moving into 10 to 12. So he's thinking about English 10 and how students will be able to have some choice in that regard.
Well, you know what? I'm not the expert on credits in high school. I haven't worked in a high school since I think since we worked together, Kevin, about 15 years ago. But I would guess that there's opportunities if you're looking at English is to combine an English course with technology or with coding, and kids building websites or kids creating whatever it is in order to display their learning of English. I think this just opens up another door for kids to have another way to share their knowledge and show what they've known. Mm-hmm. I don't know the technical bits about the 4 versus 2 credits and whether that combination would qualify.
Right. Okay. Good. So I think we have just. Sorry, I heard a voice there.
Oh, I said, but I'll be happy to take those questions back to the advisory council.
Well, that'd be great, Kyle. And so I think if you're open to it, Kyle, certainly I think people have your contact information in what we put out there. So if they want to ask you questions directly regarding this or have questions they'd like to go forward to the advisory committee, I'm sure you're okay with people reaching out to you.
Of course. Yeah, now one thing I didn't mention, and hopefully I have time, is each district should have a trainer that went through the train the trainer workshops. So contact that person from your district, and they should have some great resources on how to get started. Codebc.ca, like I said, is great. And there's my email address, my Twitter handle. If you want to get a hold of me, I'm happy to help you out or point you in the right direction.
Okay, we have one final question, Kyle, if you still have some time. It comes from Peter. What would you, I think you talked about this at the beginning, but what would you suggest is a good place to start to do activities for ADST as a whole school activity versus single class?
Oh, as a whole school. Well, a couple of years ago when we had to add a bit more prep time into our school, we actually hired someone to teach coding to every kid, K-6 in the school. But another great way to start is the Hour of Code. That's something that sort of happens in, I believe it's December, early December, but it's available anytime. And every kid can get on there and code for an hour and just get a little taste of it. I've seen schools that the whole school does it. You could bring down some high school kids to help out and facilitate those sessions and run kids through your computer lab an hour at a time to give everyone a little taste of it.
Yeah. I'll just add my thoughts. I was in Campbell River at an elementary school a few weeks ago and had just seen a presentation. So the vice principal there had had the gym, and with the intermediate class had organized an entire makerspace day. So kids were expected to bring in all different types of materials, and they spent the entire day just with some criteria, but just working together as teams and building. And I thought, really what a great way to celebrate and launch this whole ADST curriculum.
Yeah, that's brilliant. I hadn't even talked about makerspaces, but yeah, that's ADST without technology.
Yeah, absolutely, and I see it happening all over the province. I was in Vancouver Island North a couple of weeks ago and just delighted to see. I walked into a classroom and it was full of beams and lumber, and the principal said, "This is our primary construction program." And I thought, well, that's brilliant. Great to, giving kids these opportunities sort of to really build and create and have fun, and he was willing to take, a bit of a risk that goes along with that as being a school leader.
Yeah, our school has, actually our district has maker carts that they've created, the high school kids have created, and every school has one. It's got a bunch of tools in there and a bunch of, lumber, and we can pull it into a classroom and turn that classroom into a little mini shop.
That's excellent. Yeah. So Kyle, we're at 8 o'clock. I think I'm going to bring our webinar presentation to a close. Thank you so much for bringing this to our members, and certainly we really appreciate the role that you play in the Provincial Advisory Committee. Really looking forward to where this is going. I think your webinar today was excellent in terms of just giving us the provincial perspective and really providing some really good starting places for our school leaders to support this initiative. And I just love how you really were able to, one of the starting places really was talking about how we name things, about ideating and creating, and it doesn't necessarily have to be about the technology. It's just creating the space for kids to do this. So thank you again for your webinar. I think as you sort of continue to work on this advisory committee, we'd certainly love to have you back to provide another webinar for us just to give us some updates, because it certainly seems like there's lots of interest out there in the field.
I'm happy to do it. I'll just keep learning.
Okay.
Thanks, Kevin.
That's a good way to close. Thank you, everyone, for being a part of this.